to do some review. I'm going to skip around just a little bit because we've got a week of, this is so crazy. I have to administer SBAC tests because I have a lot of juniors. So we're going to miss some class time. So I want to kind of get going on moving into the most important parts of the year, which is we've got really 2 units left. This one's a little shorter one, and then it sets us up for the big unit, which is where everything kind of all comes together at the end. But to make sure we get there, I'm going to kind of skip around a little bit. I want to have plenty of time for this stuff, so I'm going to skip the last section from the chapter 7 in your textbook, the bond variation. We'll come back to that at the very end of the year. It's good stuff to know about, but it's not so crucial. We can kind of hit it at the end. And we're going to jump into, so if you're like in your textbook, this is our new unit, but it starts with chapter 7 in your textbook. So this is really just the stuff from the first section of chapter 8. So we're going to deal with radicals and radical functions. Okay, and this ultimately, why is this so important? Because it's going to give us some good techniques for solving equations that are really efficient. Okay, and we have to know how to solve equations that involve radicals too, right? And so that's something that you guys probably haven't ever seen before. So we'll look at some stuff like that too. But for now, we just have to review the concept of what's a radical, right? So radicals and roots. So to find a square root of a number a, you guys, and this is all stuff you've talked about many times. To find the square root of a number a, we're just finding the number that was squared to get a, right? So for example, you could all tell me that 8 squared is 64, and so therefore, what's the square root of 64? Square root of 64 is 8, right? Yeah, because 8 squared is 64, the square root of 64 is 8, right? Okay, now there are 2 numbers that you can square to get 64, though. You could square positive 8 or negative 8, right? And so technically, there are 2 roots that you can get. You can get the non-negative or the principal square root. That's really important. This is, when we talk about a square root, we are talking about the principal square root. Like that's we don't always want to say all those words, but if I say the square root of 64, I'm talking about the positive square root of 64. There's also a negative square root of 64, but for now, that's not going to be so important to us. Where that's going to come into play eventually, and here's where we're going with this. Like when we're solving equations, we want to be able to solve an equation, really simple one like that. Okay. X squared equals 16. Well, right now, what we would do, based on what we've done in the previous couple units, is we would set that equal to 0 and factor it, right? We push the 16 over to the left side, and we'd get x squared minus 16 equals 0. And now we've got a polynomial equation in standard form, and then we'd factor that. How does x squared minus 16 factor?
X plus 4.
There you go. And that gives us the 2 solutions, either x equals negative 4 or x equals positive 4, right? Okay, there's another way to do that though, right? You guys, and maybe you're familiar with this, or you could guess. What's another perhaps simpler way that we could solve that? We could square root both sides, right? If I square root both sides, what's that give us? Okay, so you guys already, you know that somehow we need to get the answer x equals plus or minus 4. Is that everybody, you guys are familiar with the idea that you need that plus or minus there, right? But I bet you don't know why. Why do you need that plus or minus there? How does that show up algebraically? It makes sense that it has to be there.
Positive 4 or negative
4. Okay, but what is the square root of 16? The square root of 16 is 4. It's 4. It's not plus or minus 4. The square root of 16 refers to the principal square root of 16, which is positive 4. And so the question is, how are we getting that plus or minus? I'm going to answer that question today, but I'm going to leave it hanging for now. We'll come back and finish this later, right? But wouldn't you agree? I mean, and you guys are going to be able to jump right from when you're doing problems like this, you don't have to show these intervening steps every time. You can just jump right to there. And there's going to be a rule that we have when we're taking an even root of both sides. Because that's even, we need to have a plus or minus in front of our answer. And that's sort of a working rule that you can use when you're solving equations. Now, I want you to understand the theory behind that, why it's that way. And we'll talk about that today. But in the future, that's a really quick way to get solutions. It's a little quicker than that, isn't it? Right? So using this square root property, where we can square root both sides of an equation, is a really handy way to solve equations. Okay, but we'll get there. Okay, so moving forward. So what's the anatomy of a radical expression? Pretty simple. We've got the radicand is the part that's inside the radical, and the radical sign is just the type of radical that we're using. Could be square root, could be a cube root, could be a fifth root, could be an nth root. So again, summary, if a is a non-negative number, can't be negative, we'll talk about why later, the square root of a is the principal square root, and negative the square root of a is the negative square root. Again, this is the one that we always talk about, is the principal square root. We rarely ever would even talk about the other one. It exists, but we'll always refer to the principal square root. Little practice, very simple practice. We're starting small scale here today. First one, what are we getting? 7. 0. What about that one? Everybody get that, right? Because what would I have to square to get 25 on the top and 16 on the bottom? I'd have to square 5/4, right? Okay, what about D? 0.6, yeah. What do I square to get 0.36? I'd square 0.6. Okay, what about this guy? Okay, now here's where we have to be a little bit careful, right? Because the answer, everyone tells me x to the 4th. True story, but we made an assumption there. We made an assumption that people rarely ever really consider. We assumed that all the variables represented positive numbers. Okay? And that gave us that answer. Okay? But we'll look at some other cases in the future where we got to be a little more careful with that when we're square rooting, taking an even root of an even power. What about this one? 4x to the 7th. Oops. Square root of 16 is 4. Square root of x to the 14th is x to the 7th. Good. Okay. How about this one?
-2.
What about that negative? How does the negative impact things?
It tells you not to use the
Okay, it remains on the outside. Good. And really, we're just following order of operations. How does a radical fit into order of operations? Anybody know? If I'm talking PEMDAS? Where does that square root fit in there? E. Yeah, it fits in for E. How come?
It's just the reverse of exponent.
Okay, it's a radical. We'll talk about this, but does anybody know the answer? A radical is the same thing as what kind of an exponent?
Negative?
Not negative.
Oh, decimal.
Well, I mean, it could be, in general, a fractional exponent. Okay, so a square root is the same as a 1/2 power. We'll talk more about this soon. A cube root would be the same as a 1/3 power. A fourth root would be a 1/4 power. So for that reason, those always fit in with exponents, right? So when we simplify something like this, e comes before m, before we multiply by that coefficient. So the square root of 4 is 2, and then we multiply by the negative coefficient, and we get -2. How about h? Not possible, right? How come? Well, what number could you square to get -4? Nothing. If you square a real number, the result is always non-negative. Could be 0. How could I get 0? 0 squared is 0. But any other number squared is going to be positive, right? And so this one is not a real number. Okay? It's a different kind of number that we'll talk about, but not today. Question? Nope. Okay, so how do we deal with square roots? Now, I'm not going to get into all the nitty gritty of simplifying big square roots today, but we'll do that, like tomorrow. Square roots of perfect square radicals simplify to rational numbers. Okay, we're not going to end up with any square roots left in our answer, in other words. Square roots of numbers that are not perfect squares, like 7 or 10 or something like that, always end up having square roots stuck in the answer, which makes them irrational. If a simplified number has a radical in it, it is irrational. If you wrote it as a decimal, what would it look like if it's irrational? What are the characteristics of an irrational number when written as a decimal? It has no pattern, and it goes on how long? Forever. Yeah. Doesn't repeat, doesn't terminate. And if we wanted to, we could provide a decimal approximation of an irrational number. But know that it's always going to be an approximation. It's never going to be exact if we do that. Right? Okay. Cube roots. Well, cube roots work the same way, right? We know that the cube root of A is equal to B if and only if B cubed is A. So you guys, you're familiar with this. Let's look at some quick practice examples. What's the first one? 3. Yeah. Ooh, second one, I've got a negative inside the radical. Is that okay?
Yeah.
It is for a cube root. In fact, okay, let's make a prediction. Could I have a negative number inside an 8th root? No. Could I have a negative number inside a 9th root?
Yes.
Yes. It has to do with whether the index of the radical, the type of radical that we're talking about, the index is just the number that determines the kind of radical. If that's odd, it's okay to evaluate a negative number, an odd root of a negative number, but not an even root. So what is the answer to B? Negative 4, yeah. How about C? 3/4? Okay, good. And what about D?
Negative 2 x squared.
Okay, good. So we break it into parts. The cube root of negative 8 is negative 2. And the cube root of x to the 6th is x squared. Now, I want to make a point here also. We don't have to make that assumption here. We did previously, and this is a really subtle point. It's not like it's that big a deal, but when we did this page here, we had to always assume that all the variables represented positive numbers. Okay? Look at that page. How come I don't have to do that here? Because they're cube roots. And if I can take cube roots of negative numbers, right? So we don't have to make that assumption. Okay, we can do other roots too, right? N could be bigger than 3. The index of the radical could be something like 4 or 5. What would A be? It's a race.
It's 4.
It's 4, yeah. How do you know that? Because 16 squared is 256. Okay, how about B? Negative 2. How about C? Yeah, the negative's on the outside, so it's okay.
It's okay.
Okay, and how about this one? Is that the same one we did last time?
Yeah.
Okay, and do I need this statement?
No.
I do not. Okay, so now, how do we deal, what if we don't want to make that statement? What if we don't want to make this assumption? Because we don't. We don't want to make the assumption that all variables represent positive numbers. We'd like variables to be able to be anything, right? So then what happens then? Well, if n is an even positive integer, then the nth root of a to the n, if n is even, is always equal to the absolute value of a. Okay? So for example, what would be here's the big one that we need to finish our previous example that I started when we were solving that equation. what if I want to take the square root? So there's an invisible 2 that sits on the radicand, right? Of a square root. We never write it, but a square root is a second root. What does this tell us the square root of x squared should equal?
X.
Should equal x. Yeah? Everybody's. I disagree.
Wait, what?
Let's do a test. Let's do a test here. So let's take a function. Let's say f of x equals the square root of x squared. Okay, we'll do a little test here. Let's evaluate this. What's f of 2? That's the square root of 2 squared, which is the square root of 4, which is what?
2.
Maybe you're right. It seems to work. That would have worked if I had just said x, wouldn't it? You might be right.
No, he's gonna prove
Okay. So what if I evaluate this at -2? That's going to give us the square root of the quantity -2 squared. Well, what's -2 quantity squared? So the answer is 2. Oh, you're wrong. Okay. Yeah, if I plug in a -2, I get back a +2. So what's going on? So it's not, that can't be x then.
Oh, it's plus or minus X.
Okay,
It's the absolute value of x.
absolute value of x.
That's why it says the line, don't it?
Because it always, right, if we take an even root of an even power of a variable, it always ensures that we're getting a positive outcome, doesn't it? We just proved that, right? So we need those absolute value symbols. Okay, so now we can go back. Let's go clear back to the beginning, and we can resolve our issue here, right? When we took the square root of both sides, people typically think the plus or minus is coming from the 16, but it's not. The square root of 16 is 4. The square root of x squared, however, is the absolute value of x. And we did a bunch of stuff with this at the very beginning of the year. If I solved the absolute value equation, the absolute value of x equals 4, what are my solutions? Plus or minus 4, right? That makes sense? So that's where that plus or minus comes from, is the absolute value, right? But again, we can just skip down here. But now you know why. Now you know why you include that plus or minus when you're solving an equation by square rooting. Okay, so, oh, do that. Where were we? We're about done. Okay, here. So what is the answer to A then? I'm taking an even root of an even power. So the second root of the quantity -4 to the second power is the absolute value of -4. But we know what that answer is. What is the absolute value of -4? It's 4. So we can just simplify that to 4. Okay, what about B? Square root of x to the 4th then would be what?
X squared.
Okay, it's x squared, but because I'm taking an even, this is the same thing as saying, right? This is the same thing as saying the square root of x squared squared, right? Agreed?
Yeah.
X to the 4th is just x squared squared. So if I take a square root of hand squared, isn't that just the absolute value of hand? That's how it was up here, wasn't it? Right? So technically, that's the absolute value of x squared. Now, I disagree with the book's answer here, though, because x squared, do I need absolute value bars around x squared? I really don't. How come? Because it's always positive, isn't it? Right? Agreed? So you could simplify this one down to x squared, because x squared is always positive value, regardless, if you're talking about real numbers, right? Any value you substituted into x, positive or negative, is going to give you a positive outcome, right? So we still don't have to make any assumptions here. Even a negative number squared is positive, so we don't need the absolute values. Okay? That makes sense? Okay. How about C?
Absolute value.
Okay, this time I do need an absolute value, don't I? Right? Because I've got an even root of hand to an even power, right? Sixth root of hand to the sixth, those are 6 is even, tells me that I need absolute values there. And I do need them this time because there are some values of x that would otherwise give me a negative outcome, right? Agreed? Like if I pick, for example, 0, right? If I pick 0, that would be a problem. Okay? Make sense? Okay. How about D? Do I need absolute value bars there?
Because it's cubed.
But it's cubed, and that's an odd power, right? So for odd numbers, if I take an odd root of an odd power, I don't care because negative numbers are okay inside an odd radical, right? I don't need the absolute value bars there. That's the only reason I needed them up here, right? Don't need them in this case. So I would just get 8 or negative 8. Okay. How about that one? Do I need them? No. And effectively, what's going on here? Effectively, the 7th root is canceling the 7th power, right? And I just get 3x minus 7. Okay. How about this one? Square root of 49, 7. Square root of x squared,
Absolute value.
absolute value of x. Right? Even root of an even power. Okay. How about this one?
Wait, you can factor it inside.
I'd have to factor it. Good. Now, I couldn't do anything else otherwise, could I? Because, like, I can't say, for example, would you guys agree? If I have the square root of 16 plus 25, is that equal to 4 plus 5? No, I can't do that, can I? Right? Can't do that. And I can prove it. 16 plus 25 is not 81, right? And 4 plus 5 is 9. So I would have to get 80. That doesn't work, right? You can't, that's not a property. That doesn't work. The only way I could do this problem in G is if it factors into a perfect square, right? Perfect square trinomial, and it does. How does x squared plus 4x plus 4 factor? X plus 2 quantity squared. There you go. Good. So because that's x plus 2 quantity squared, what's my answer going to be?
Absolute value of x.
Absolute value of x plus 2. Good. Okay. Good. All right. So then last issue. Okay, just evaluate it. This is no big deal, right? So we're just going to evaluate some radical functions. So f of x is the square root of x minus 5. G of x is defined as the cube root of x plus 3. What's f of 9?
2.
It's 2, isn't it? Yeah. It's 2. How come? Well, because the square root of 9 minus 5 by PEMDAS, I'll work inside my implied parentheses, implied grouping symbols. The square root groups everything inside. Square root of 4, 2. Okay, how about f of 11? Square root of 6, and I can't go any further, can I? Right? G of negative 2. 1, okay. Yeah, because I'm going to get G of negative 2 plus 3 is cube root of 1, which is 1. Okay, and then finally G of 3. Cube root of 6. I can't go any further. Cube root of 6 is what I'm stuck with. Okay, what about the graphs? What's a graph of a square root function look like? Well, a square root graph has an endpoint. It starts at the origin, and then it just kind of progresses to the right and up like so, right? It flattens out. It flattens out a little bit. How come? Because the input numbers are going to grow faster than the output numbers, right? Think about that. If square root of 1 is 1, so they seem to be growing at the same rate, but then I've got to go all the way up to 4 for an input to only get 2 for an output. I have to go all the way up to 100 for an input to only get 10 as an output, right? So the outputs grow decreasingly fast. They grow increasingly slowly, I guess I could say, with respect to the inputs as the inputs grow. So it's going to tend to curve downward, flatten out. What do we get for a cube root function? Is it going to look like that?
No,
What's going to be different about a cube root?
it's gonna go up. No,
It's gonna be like swiggly.
It's going to look pretty similar, right? Because think about it, just the rate at which they grow is just a little bit different. But again, inputs are going to grow faster than outputs for a cube root, right? I have to go all the way up to 8 for an input to get an output of 2. I have to go all the way up to 1,000 to get an output of 10, right? So it's going to be kind of squished down where it flattens out a little bit faster. But it has to go the other way too, right? Because for a cube root function, I can input negative numbers. The reason this guy stopped was because I can't input into my t-table any negative numbers for a square root, right? They're undefined. Okay. But for a cube root function, I can. I get something like that. Okay, make sense? All right. I will put up an assignment. Having a little technology issue right now, but it'll be up very soon.